Hi, this is Scott from CircuitBasics.com. In this video, I'd like to show you how to set up and program an LCD on the Raspberry Pi using I2C. So why would you want to use I2C to connect your LCD? It only uses 4 GPIO pins, including the power and ground wires. With other ways, you have to use 8 or 12 pins to connect your LCD. There are a couple ways to use I2C with an LCD display. There are LCDs that have an I2C backpack attached. In this case, the wiring is pretty self-explanatory, so I won't go over how to connect these displays, but I will go over the programming. The way I'll be showing you uses a plain old 16x2 LCD and an IC chip called the PCF8574. You can find these on Amazon or eBay, and they're pretty cheap. This is all you really need to use I2C to connect your LCD to the Pi. After showing you how to connect the LCD, I'll show you how to program it. I'll show you how to do stuff like scroll text, print data from a sensor, turn on and off the cursor, and print custom characters. All the example code I'll be using is posted on the Circuit Basics blog, and I'll put a link to the post in the description of this video. So let's get started wiring up the LCD. I've got my Pi and a breadboard here, so I'll insert the LCD into the breadboard. Now I'll insert the PCF8574 into the breadboard, with the notch oriented to the left, the side closest to the Pi. Here's a diagram of the pins of the PCF8574. Notice the notches on top here. You might want to get a screenshot of this because I'll be referring to these pin numbers. I'll start by connecting the VCC pin of the PCF8574 to the positive rail of the breadboard. Then I'll connect the SDA pin of the PCF8574 to the SDA pin of the Raspberry Pi, pin 3. All the pin numbers I'll be talking about here are the physical GPI locations on the board of the Pi. Now I'll connect the SCL pin of the PCF8574 to pin 5 of the Pi. I'll connect pin P7 of the PCF8574 to data pin D7 of the LCD. Pin P6 of the PCF8574 connects to data pin D6 of the LCD. Pin P5 of the PCF8574 connects to data pin D5 of the LCD. And pin P4 of the PCF8574 connects to data pin D4 of the LCD. Now I'm going to connect the 2 positive rails of the breadboard. And then the 2 negative rails. Now I'm going to insert a 10K ohm resistor between pin A0 of the PCF8574 and the positive rail of the breadboard. I'm going to connect pin A1 of the PCF8574 to the negative rail of the breadboard, and pin A2 of the PCF8574 to the negative rail of the breadboard as well. Now I'm going to connect pin P0 of the PCF8574 to the RS pin of the LCD. Pin P1 of the PCF8574 to the RW pin of the LCD. And pin P2 of the PCF8574 to the E pin of the LCD. Then I'll connect the ground pin of the PCF8574 to the negative rail of the breadboard. Now I'll connect the VSS pin of the LCD to the negative rail of the breadboard. The VDD pin of the LCD connects to the positive rail of the breadboard. Then I'll insert a 10K potentiometer for the contrast control, and another 10K potentiometer for the backlight brightness. The VE pin of the LCD connects to the center pin of the backlight brightness potentiometer. Then I'll connect a jumper wire from one side of the potentiometer to the negative rail of the breadboard. I'll connect the A pin of the LCD to the center pin of the contrast potentiometer. And then connect one of the side pins of that potentiometer to the positive rail of the breadboard. Then I'll connect the K pin of the LCD to the negative rail of the breadboard. The last step is to connect the power and ground wires to the Pi. So I'll connect a jumper wire from the negative rail of the breadboard over to pin 6 on the Pi, and then the positive rail of the breadboard over to pin 2 of the Pi. Now I'll just adjust the contrast. And the backlight brightness. And we're good to go. So now let's get into the programming. I'm assuming you've already established a connection to your Pi, like a SSH connection, anything where you can access the command prompt. I'm using PuTTY, so I'll just log into my Pi here real quick. And the first thing we'll need to do is enable the I2C interface on the Pi. So enter sudo raspi config. And scroll down to advanced options. Now scroll down and select I2C enable disable. Choose yes. Okay. Yes. Okay. Now exit and reboot. So now the next time we boot up, the I2C module will be enabled. Let me log in again. Now we'll need to install a couple programs. The first program will help us find out the I2C address of the LCD. The second program is SMBus, which is needed for the Python library we'll be using to program the LCD. Enter sudo apt-get install I2C-tools. Now enter sudo apt-get install python-smbus. Now do a reboot. Log back in. Now we can find the I2C address of the LCD connected to our Pi. Enter I2C detect -y1, and that will generate a table of all the I2C addresses connected to the Pi. See this number right here, 21? That's the I2C address of my LCD. Your number will probably be different, but write that down. We're going to need it in a minute. It took a while, but I searched around and finally found a library that works with I2C. I posted the code for it in the Circuit Basics blog, and I'll leave a link to this in the description so you can copy the code. There's also a diagram for connecting the LCD, and the steps for enabling I2C and installing I2C tools in SMBus. Here's the code for the library. So I'll just copy this. I'm going to create a new file called I2C_LCD_driver.py. Then right-click to paste that code in there. Now there's a couple lines of code in the library you'll need to change. You'll need to put the I2C address of your LCD in there, and also the I2C bus of your Pi. If you have an older Pi, it probably uses bus 0, but if you're using a newer Pi like the Revision 2 board or newer, it probably uses bus 1. You can change the bus number right here in line 19 of the library code. And then here in line 22, you'll need to put the I2C address of your LCD, the one we found earlier using I2C tools. I'm using the Raspberry Pi Model 3, so I'll change this to bus 1. And my I2C address is 21, so I'll change this to 21. Save and exit. Now we're ready to run some programs. I'm going to show you examples of the basic functions this library provides, but this isn't everything you can do. Try mixing some of these programs to get some interesting effects. We'll start with a basic Hello World program. The function myLCD LCD display string will print text to the screen. I'll just copy this. And we're working in Python here, so I'll create a new file called lcdtest.py. Paste that in there. To run it, we just enter sudo python lcdtest.py. And there you go. Hello World is printed to the display. You can position the text anywhere on the display by adding numbers for the rows and columns in the myLCD LCD display string function. Inside the parentheses, you have your text in quotations, followed by the row number, then the column number. The rows are numbered 1 to 2, and the columns are numbered 0 to 15. This program will print Hello World to the bottom row, 4th column. Here's a little trick. Instead of re-entering commands manually, you can use the up and down arrow keys to scroll through previous commands. And I'll just get rid of this with Control K. I'll paste that in there. Then run the program. So Hello World is now printed to the bottom row, 4th column from the left. Now let's see how to clear text off the screen. You can do that with the function myLCD LCD clear. This program will print "this is how you" for a second, clear it, and then print "clear the screen." Pretty basic stuff, but it can be really useful. We can use the myLCD LCD clear function in a while loop to create a blinking text effect. This program will print Hello World to the screen, wait for 1 second, clear the screen, wait for another second, and then loop back to printing Hello World again. So there's our blinking Hello World text. Press Ctrl C to exit the program. Here's a program that will print the date and time to the LCD. Okay. You can also print the IP address of your Pi pretty easily. This program will print the IP address of my Ethernet connection to the display. You can also print the IP of your Wi-Fi connection. Just come down here to line 18 and change the ETH0 to WLAN 0. There it is, 10.0.0.24. Scroll Scrolling text is really useful if you need to display text that's too long to fit on the screen. This program will scroll a text string from right to left. And this will loop around continuously. You can also scroll text onto the screen just once, leaving a blank screen when the program exits. You can scroll text in from the left side too, but I wasn't able to get it to scroll infinitely. It only scrolls once and then leaves the beginning of the string on the screen after the program exits. Okay, custom characters. So each character of the LCD is a grid of 5 by 8 pixels. You can make any pattern within that grid and print it to the screen as a custom character. I have a link here to a website that will help generate the code you need to define the custom characters. This is the part you need. And that will go here. So the first thing you'll need to do is define the custom character like we do here. Then you load the character in the LCD memory with MyLCD LCD load custom chars and put the name of your custom character in the parentheses. You can then write the custom character with the MyLCD LCD write char function. Let's try it out. So there's my custom character printed to the screen. That's just a single custom character, but you can define up to 8 custom characters and print them to the LCD at one time. You define the custom character just like we did in the last example, but put one after the other. The first defined character is automatically assigned a value of 0. The second has a value of 1, and the third has a value of 2, and so on. Down here, we load the custom characters in the LCD memory with mylcd.lcd underscore load underscore custom underscore chars. Then we write each character using mylcd.lcd underscore write underscore char with the number of the character we want to print in the parentheses. So this will print 6 custom characters that together will form a large right-facing arrow. So there you have it. Okay, now on to the final example, how to print data from a sensor. I'll be using a DHT11 humidity and temperature sensor to demonstrate, but this will work with any sensor. All you need to do is insert the variable from your sensor into the mylcd.lcd_display string function, just like you would any other text string, except without the quotation marks. I'll just connect the DHT11 here real quick. I'm connecting the signal pin of the DHT11 to pin 7 of the Raspberry Pi. Connecting the negative pin of the DHT11 to the negative rail of the breadboard. And the 5-volt pin of the DHT11 to the positive rail of the breadboard. I'll open up our example program. And clear the old program out. Then paste the DHT11 example code in there. So there's the temperature and humidity displayed on the LCD. That was pretty easy. Well, that should about wrap it up. Hope this video has been able to help you get your LCD working with I2C. And let me know in the comments if you have any questions. And be sure to like and subscribe if you enjoyed it. Alright, thanks for watching. I'll talk to you next time. Bye-bye.